exercise 8A. This is the second episode on this exercise. And I'm trying to adjust my camera. Okay. So we already have done one episode on it. In that episode, we did question number 1 and question number 2. There were a lot of parts in them. And today we are going to start the work from the question number 3. This exercise is about increasing and decreasing functions, and by using the first derivative we are going to find that whether the function is increasing or whether the function is decreasing. We are solving the course book of the pure mathematics one. This is A levels mathematics 9709. This is the second episode on the exercise 8A. So let's start from the question number 3. And let me read the question so that we do not make any mistake in writing the question. He says, find the set of values of x for which the f of x, which is 1 by 6 bracket start 5 minus 2x bracket close raised to power 3 plus 4x is increasing. The function is increasing. We have to find the values of the x for which this is increasing. Okay, so what we will do, let me do that. So first of all, we are going to find out the derivative. So I'm going to differentiate it. So f of x will be equals to 1 by 6 will remain as it is. The power will come on the side. 5 minus 2x, its power will decrease by 1, so it will become 2. Then I will write the derivative of this base, which will be 0 minus 2. Then the derivative of 4x will be 4 only. So the derivative is, this is 1 by 2, 2 cancel. So you will have minus 1 into the 5 minus 2x raised to power 2. And this will become plus 4. Okay. So I can open it, and you see, if I open it, then what will happen? This, so you can understand it easily. This will become 25 minus 10x minus 4x square plus 4. So the derivative of this thing will, I'm just simplifying it, okay? Minus 25 plus 10x, this should be positive, okay? So minus 4x square and plus 4, okay? So, okay. So I can write it like this. The f of x, derivative of the f of x is minus 4x square. Then you have plus 10x. Then you have, this becomes minus 29. Or not 29, 21. I mean, 21. Okay? So, because we want the f of x to be increasing, he said f of x is increasing. So, for the f of x to be increasing, the derivative must be greater than 0. Okay, so that means that the minus 4x square plus 10x minus 21 should be greater than 0. This expression is very important. Okay, so I will find the you can see, if I will simplify this, this will become this, because I expanded this. I can write like minus 4x square plus 10x minus 21. Let me say it is equal to 0. So this can be written like this, okay? Minus 1 into the 5 minus 2x whole square plus 4 equal to 0. So this is minus 5 minus 2x whole square equals to minus 4, and this will become minus cancelled. So you will have 5 minus 2x whole square is equals to positive 4. Take square root on both the sides, so you will have 5 minus 2x equals to plus minus 2. So 5 minus 2x will be equal to the positive 2. Minus 2x will be equal to the 2 by the 5. Not 2 by 5, sorry. 2 minus 5 and minus 2x will be equal to the minus 3. X will be equal to the 3 by 2. So one x-intercept will be at the 3 by 2. The other one will be so you will have 5 minus 2x equals to minus 2. So minus 2x will be equals to minus 2 minus 5. Minus 2x will be equals to minus 7. Minus minus cancel. So the x will be equal to the 7 by the 2. So these are the two x-intercepts. If you look at this shape, here, look at here, why I expanded this. Now you can understand it easily without any mistake that this is a quadratic and its x squares coefficient is negative. So it's a sad face. And so I can say that it's a sad face. So you can say, if I will draw its graph, this is my y equals to 0. You can say here, the sad face, it's a sad face, so the graph will be something like this. Okay, so this and this is the x-intercepts. One of them is this is 1.5, so this is 1.5. 3 by 2 means 1.5, and this point is 3.5. Okay, we want the graph to be positive. We want the graph to be above this red line, y equals to 0. We want the graph to be positive. So the graph is positive in this area. In these x values, the graph is positive. So my x answer will be that the x should be greater than 1.5 and less than 3.5. So I hope that this is the answer. If we have not made any mistakes, our answer is right. In the book, the answer is 1.5. X is greater than 1.5 and x is less than 3.5. So this is how you will do this. This is exercise 8A, the second episode. This video is the second episode on this exercise. And this is question number 3. So this is how you will exactly find the values of the x. And the range of the values of the x is greater than 1.5, less than 3.5. I hope you understand this. The question is in front of your screen. So let's go to the next one. The next one coming up on your screen is the question number 4. So let me erase it. I hope you have done this. So the question number 4. Okay, so we will work on the question number 4 now. Question number 4. In the question number 4, they say question number 4 of this exercise. The function is defined as the f of x is given, and that is equals to 4 divided by 1 minus 2x. For x greater than and equals to 1, find an expression for another important thing is that the x is greater than and equals to 1. You cannot take the values of the x less than 1. Okay, the values of the x, this is given in the question. And he says find an expression for the f of x. And he says first question is find the expression for the derivative of this. And then they say and determine whether f is an increasing function or a decreasing function or neither. Okay, so let me first of all find the f of x, the derivative of the x. So the f of x is given, that is 4. I will bring this upstairs. So its power will become negative. So then I will find its derivative, and that will be equals to 4 into minus 1 into 1 minus 2x raised to power minus 2. Then I will take the derivative of this base, and the derivative of this base will become 0 minus 2. Okay, so the derivative of this thing will become minus minus plus, 4 2s are 8. So this will become 8, 1 minus 2x raised to power 2. Okay. Now, we have found the derivative. If you look at the expression we have got for the derivative, no matter, this is the first part. In this, no matter if you put any value which is greater than 1. So put any value greater than 1. So because here you have whole square and this is positive 8, if you put any value greater than 1 of the x here, then because of this whole square, this whole thing will be always positive. Okay. So for any value of the x greater than or equals to 1, the dy by dx will be uh, always greater than 0. So it's an increasing function. No matter what you the value, take any value greater than 1. For example, you put x equals to 2 or x equals to 3 or x equals to 4. Because of that whole square, the answer will be positive, and this is already positive, so the answer of your derivative will always be positive if you put any value of the x greater than 1. So we think that this is an increasing function. This is question number 8A exercise, and it's question number 4. If the answers are right, sir, this is how you will solve. This is purely concept. So I hope you understand. This is how you do the question number 4. Because for any value of the x greater than 1, the dy by the dx answer or the derivative answer will be positive. And that is positive. Why I know that is positive? Because of this whole square. Even if a negative comes here, due to this whole square, it will become positive. I hope you understand this. Okay, so we are going to the next question. The next question will be the question number 5 of the exercise 8A. This is the second episode we are doing on this exercise. So, question number 5. Question number 5, sir. Question number 5. Here you have question number 5. He says a function f is defined as. Here we have a function f of the x is equals to 2 divided by x plus 2 whole square. Then you have minus 2 divided by x plus 2, and they have given for x greater than and equals to 0. Find an expression for the derivative. Okay, we have to find an expression for the derivative. Okay, this is their question. Find an expression for the derivative and determine whether the f is an increasing function, a decreasing function, or neither. Okay. So first of all, let me find out the derivative. So what I will do, let me write the f of x is equals to, this will become 2 into the x plus 2 raised to power minus 2 into the x plus 2 into the. So I have converted this expression into a friendly form, so where the derivation can be easy. So then we will have f of x. I will take the derivative 2. The minus 2 will come on the side. The power will be decreased by 1. And then I will take the derivative of this base. The derivative of this base will be 1. Then you have minus 2. The minus 1 will come on the side. Then you will decrease the power by 1. So it will become minus 2. Then the derivative of this base will be only 1. Okay. Now, let me sit. Okay. So now what will happen? I will find out I will simplify it further. So this becomes minus 4 divided by x plus 2 raised to power plus 3, and this becomes positive. and this is a negative, okay, and this becomes plus 2, okay, this is 2 divided by the x plus 2 and whole square. So you see, you have to think very clearly whether if you put, you see the x values you have to take are all positive. The 4x greater than and equals to 0. You see, this is given in the question. If I will put any positive value here, so this will be always negative, means for all the positive values of the x, if I put here, so this will be always, the negative. Okay, for example, if you put 1, then it will be negative, this will be positive. So I can, how we can predict, let me check the answer first of all, that my derivative is right or not. They have taken the LCM and then they have, okay, so let me take also the LCM. If I take the LCM, then what happens? So let's see what happens. They are further simplifying it. I have not done it. Okay, so I will take the LCM. The LCM will be this. So when you divide this, this is minus 4. When you do with this, you will left with the positive 2 into the x plus 2. So this will become f of x equals to, this is minus 4 plus 2x plus 4. So divided by the x plus 2 whole raised to power 3. Oh my God, yeah. So this becomes only 2x divided by the x plus 2 greater than raised to power 3. Okay. Now, let me check again the answer that I simplified it further. Okay. Now, the derivative's answer is 8. Is this 8? Divided by, this is 8a, question number, we are doing question number 4. The answer is 8 divided by 1. So we made some mistake here. We made some mistake here. Yes. This is. Let me check if what mistake we did. We have made some mistake. Oh yeah. We are working on question number 5. Sorry. Question number 5. The question number 5. The answer is 2x minus. He says 2x minus 8. We made some mistake here. So what is the mistake? This is 4. And what happened here? It's 2. So 4 into, my answer is coming to x. There is something went wrong here. And let me check again. Let me check the question again. Oh yes, we have not, by mistake, what happened here? This was 5. Sorry. So this is 5. So this number is 5. So this number will be minus 10. So this number is minus 10. So this number is minus 10. So this number will be 2x minus 6. Okay. So let me come on this. When I noted down the question, I by mistake wrote here 2. This was basically 5. So let me bring it here and let me explain to you that is this increasing function or decreasing function. So you see what happened here. The answer of my derivative is 2x minus 6 divided by x plus 2, the whole thing raised to power 3. In this expression, if you will put, for example, you have to take the values of x greater than 0. For example, I take 1. Suppose I take 1. So what will happen? Let me check. So it will become 1 minus 6 divided by 1 plus 2 raised to power 3. So that is 2 minus 6 divided by 3 cubes are 27. So that's minus 4 divided by 20. Negative means decreasing. So at this point that is decreasing. But let me take some big number. For example, I take, let's say take 3. Let's take 4, okay? So when I take 4, so what will happen? 2 into the 2 minus 6 divided by, this is 2, I take 4, sorry. This is 4. 4 plus 6 is 4 plus 2 whole cube. So it will be 8. 8 minus 2 is positive 2 divided by this is 8 cube. And this is positive. So now the function is increasing. So when you put the x values greater than 0, on some values you see the function is showing it's decreasing. On if you put more larger values of the x, then it becomes increasing. Okay, so after x is greater than 0, it is increasing as well as decreasing. So we can say neither. We will say neither. This is the answer, sir. Because on some values of the x greater than 0, the function becomes decreasing. On some values greater than 0, the function becomes increasing. So you cannot say overall that it's an increasing function or a decreasing function. So our answer is neither. We cannot decide it. Okay. The question was, when I was writing this question, by mistake on the first, the first fraction there in the function, instead of writing 5, I wrote 2. So that's why it created a little mistake. So the question was, a function is defined by f of x equals to 5 divided by x plus 2 whole square minus 2 divided by x plus 2. For x greater than 0, equals to 0 or greater than 0, find an expression for the derivative of the function and determine whether f is an increasing function, a decreasing function, or neither. So our answer is neither. So a little complication in it, okay, but not that difficult. I hope you understand this. We are working on the exercise 8A, which is the chapter further differentiation of the pure mathematics 1. We are working on the solution of the course book. So we are done with the question number 5. Now we will start working on the question number 6. I hope you understand this. So now we are going to work on the question number 6. It is quite hot and humid today. Today is the 9th of the September 2025. Right now I am in Sargodha, Punjab, Pakistan, and it's quite hot and humid. So we are working on the question number 6 now. The question 6 is, show that the f of x, we have to show that the f of x is, which is equal to x square minus 4 divided by x. We have to show that this is an increasing function. So let me read the question very carefully so we do not make any mistake in writing the question. Show that f of x, which is x square minus 4, the whole thing divided by x, is an increasing function. So we have to prove that this is an increasing function. The method is you take its derivative. So first of all, let me bring it into the friendly shape where I can do the derivation easily. Okay, so this will become x minus 4 into the x raised to power minus 1. So now I will take the derivative. The x derivative is 1. 4 minus 1 comes on the side. The power decreases by 1. So the f of the derivative of this function is equals to 1 plus 4 divided by the x square. So if you look at this expression of the derivative, it is 1 plus 4, and under the 4 we have x square. So no matter what the value of the x you put in it, because the x has a scale on it, even if you put the positive values, obviously the whole thing will be positive. The answer of the f of f derivative x will be positive. And if even you put a negative value of the x in it, the answer will be positive because x has a scale on it. So its answer is going to be always positive. So I can say that the derivative f of derivative of this function is always positive. Why I'm saying so? Because this x square, due to this x square, even if you take the x square, x value as negative, the answer will be positive. So the f of x is increasing function. So the f of x is, because its derivative is always positive for all the values of the x, that's why I can say that that function is increasing function. So this was the question number 6. Okay. Now we are going to the next question. I hope you understand this question. And let's go to the next question. That is the question number 7. And let's see what happens. Question number 7 is coming up on your screen. Okay, function f is defined as. So we have a function here, f of x, and it is equals to, it says 2x plus 5 raised to power 2 minus 3 for x greater than or equal to 0. Find an expression for the f of x, its derivative, This is the question, and explain why f is an increasing function. So now let me read it again. So you see, because of the very hot weather and humid and sweating, sometimes we make mistakes in writing the question on the board. So that is very important that we read the question again. Question number 7, we are attempting. A function f is defined as f of x is equals to bracket 2x plus 5 bracket close whole square minus 3 for x greater than and equal to 0. Find an expression for the derivative of this function and explain why f is an increasing function. Okay, so we have to show. Okay, so first of all, we have to find out the derivative. So I can find the derivative of this. The f of x is given to me. That is 2x plus 5 the whole square minus 3. So it will become f of x will be equal to, this 2 will come on the side, and then the power will decrease by 1, and then I will take the derivative of this base. This base derivative will be 2 plus 0. Then the derivative of minus 3 is 0. Okay, so the derivative becomes, this is 4x, 2 2s are 4, and this becomes 2x plus 5. And so this is, derivative is 8x plus 20. Okay, so this is the expression for the derivative, and you can see it is 8x plus 20. The expression for the derivative is 8x plus 20. So if I will put, if you look at here, because we have to take the x values greater than 0, equal to 0, greater than 0. So if you put 0 here, it will be, I'm just trying to explain to you. You put any value of the x here, greater than and equal to 0. For example, I put 0. The answer will be 20, which is positive. For example, you put here 2, okay, because we have to take the x values greater than 0. So 16 plus 20, that's 36, which is positive. So that means no matter what value of the x you take, but there is a condition, the x value you have to take is equals to or greater than 0. So you put any value of the x which is positive, greater than 0 means positive values. The answer of this will be always positive. So that means the f is an increasing function for x greater than or equal to 0. When you put the values of the x greater than and equals to 0, the answer of the derivative is always positive. So that means that the f of x is increasing. So this is what you have to write there. So that was the question number 7. Now we are going to the next question. That is the question number 8. That is the question number 8. Question number 8 coming up on your screen of the exercise 8A. Of the exercise 8A. Okay. This is the second episode we are doing on this exercise, and we hope we will. We hope that we will. Yes, we will complete this exercise, God willing. So we are doing the question number 8 now. Okay. So in the question number 8, it is given that f of x. It is given that f of the x is equals to 2 divided by the x raised to power 4 minus x square for x greater than 0, not equals to 0, greater than 0. Show that f is a decreasing function. We have to show that if I take the values of the x greater than 0, this function is a decreasing function. So how do we show that the function is a decreasing function? We find its derivative for this range of the values of the x. If the derivative will be no, bete, we are working. I have started working on. We have done exercise the chapter 7, which is simple differentiation of the pure mathematics. We have completed that chapter. And now I am working on the 8th chapter of the Pure Mathematics 1 course book, and this is about the further differentiation. So we have only done the chapter 7, and now we are working on the chapter number 8. So we will make its shape friendlier. So f of x will be equals to 2x raised to power minus 4 minus x square. So now I can find its derivative. So this 2 minus 4 will come on the side. The power will decrease by 1. And then you have power comes on the side. The power decreases by 1. So the derivative is equals to, this is minus 8 divided by the x raised to power 5 minus 2x. Okay. So look at this expression. It has 2 terms in it, and the x values greater than 1. What are the x values greater than 1? You can take 1, you can take 2, you can take 3, you can take 4. Put any value of the x greater than 0 here. For example, you can also put 0.5. This term will become negative. This term will also remain negative. So for all values x greater than 0, the derivative, this derivative will be negative. Okay, so that means f is decreasing. You see, this is simple logic. We have to use the logic here. You see, if the expression of the derivative which you got here, um, which is minus 8 divided by the x raised to power 5 minus 2 raised to power x, and the x values which I can use here, they told me that the x values should be greater than 0. So they will be positive x values. So in this expression, when I will put any positive value of the x, there are two fractions here. The first the first has a minus 8 in it, so that term will remain negative, and the second term also has a minus 2 in it. So if the x will be positive, both the terms will be negative. So when you will add them up, the answer will be always negative. That means the derivative's answer will be always negative for the x values greater than 1, sorry, greater than 0, sorry. And so that means that the function is decreasing. If the derivative's value is negative, that shows that that function is decreasing. So this is how you will show that. It's very logical and you have to think about it. Okay, so this was the question number 8, and now we are going to do the last question, and that is question number 9. Question number 9 coming up on your screen. This is the exercise 8A. We are doing the second episode on it, and this is the last question of this exercise. And okay, in the last question they say, question number, we are talking about the question number 9. So this is question number 9. He says, a manufacturer company produces X articles per day. The profit function P of X can be modeled by the function. So their profit is modeled by this function. And the formula is 2x cubed minus 81x squared plus 840x. Find the range of the values of the x for which the profit is decreasing. For which the profit is decreasing. Okay. So first of all, I'm going to find out the derivative of this thing. This is the function which is giving us their profit. Okay. How much profit they're making. So I'm going to differentiate it. So P of that derivative of P of x. So this 3 will come on the side, and the power of the x will decrease by 1. This 2 will come on the side, and the power of the x will decrease by 1. 840x, its derivative is 840. You see, I am finding out the derivative. So we will further simplify this derivative. Okay. So this becomes 6x squared minus 2 1s are 2, 2 8s are 16x plus 840. So for the profit to be decreasing, this function needs to be decreasing. The derivative must be negative. For the profit to decrease, the derivative must be less than 0. It should become negative. The derivative should become negative. That will show that the curve, the formula for the profit is going down. Okay, so you have here 6x squared minus 162x plus 840 should be less than 0 for the decreasing function. Divide everybody with the 6. So this will become x squared minus 2s are 12, 7s are 42, and 2 6 1s are 6, 6 4s are 24, 0 0. Okay, so okay, so I just wanted to find out the x-intercepts here. So let me write x squared minus 27x. You do not get confused with it, equals to 0. I'm trying to find out the x-intercepts. So this will become x squared minus 20x. I'm doing the midterm breaking. Minus 7x plus 140 equals to 0. The x is common, so x minus 20 minus 7 is common, x minus 20 equal to 0. So the x minus 20 into the x minus 7 equals 0. The x-intercepts are 20 and the x-intercepts are 7. Okay. Now, look at here. Now what we will do, I know the x-intercepts for this derivative expression. So now what I will do, I will draw its graph. So very simple. Just you have to pay a little attention. You will look at this original thing, this thing, this thing. What is this? This is 6x. The x squares coefficient is positive. So basically this is a happy face. So this is a happy face, okay? And this is my y equals to 0, okay? So what will happen here? There you have two x-intercepts. One is at the 7. The one is at the 7. The other one is at the 20. We want this graph of the derivative to be negative. So where the graph is negative, can you see? Can you tell where is the graph negative? Here, in this portion. The graph is below y equals to 0. So the graph is negative in the negative portion of here the value of the derivative will be negative. So the answer is very simple. The x should be greater than 7 and less than 20. This is my answer. I hope it's good. All right, our answers are right, sir. Oh my God, the answers are right. So this was the question. I hope you understand this. And my dear students, we are done with the exercise 8A. The exercise is about the increasing and decreasing functions. The name of the chapter is Further Differentiation. And there are two chapters on differentiation. One is the chapter 7 that we already have done. We have uploaded those videos. And this is the second chapter in that course book of the Pure Mathematics 1. We are working on it. We are done with its exercise 8A. So if God willing, if God permitted us, then we will do all the exercises. So thank you very much for coming online and commenting also. And I told you that this is not, it's not important, because from my point of view, it's not important that you come online when I'm live. The important thing is that when the video, the recorded video will be available on the channel whenever you have time, whether you are in your college, when you are at your home, or when you are at some office or market, and you have time, you play that video and watch these videos. If you think that this video is useful, these live sessions are helpful, please like this video. Also share the link of this video with your friends who do not have tutors and whose mathematics is little weak and they are in AS and they have adopted for mathematics. So this video can be helpful for them. For very brilliant students, we don't recommend the course book for very brilliant students. They can learn through the, the topicals. But the weak students, they need to practice the course book. So I hope that this video will be helpful to you, and your support is very meaningful and very important for me. My name is Ferhan Mazher, and it's a pleasure for me that I can make videos, and those videos can be helpful for the students of A levels around the globe. And this is a blessing for me. Thank you very much, sir. Have a good night. God bless you all.